Okay, on this question, it says two men are trying to pull a piece of farm equipment. The stronger of the two men pulls with a force of 100 pounds at a heading of north 78 degrees east, and the other pulls at a heading of south 70 degrees east. What force should the weaker man apply to his rope so that the piece of farm equipment heads due east? Round your answers to the nearest pound. Okay. So the main thing is we got to be clear on these direction things. So let me do that. So every time they say a direction, I like to just draw a little north, south, east, west. And what does it say for the first? The stronger man pulls with a force of 100 pounds, north 78 east. What does that mean? That means straight north, but 78 degrees to the east, right? North, but 78 degrees to the east. So it'd be about right here. So that makes sense. So we're doing the origin. Go north first, but then 78, 90 be all the way to here. So 78 to the east. So let's put that vector right about there. Like that. And that's 100 pounds. And this angle here is 78 degrees. Okay. Now let's do the other man, the weaker man. Another axis system for that one. North, south, east, west. That person pulls it south 70 degrees east. So south, but not pure south, 70 degrees this way, 70 degrees towards the east. So it's going to be like about right there. Is that making sense? You always start with what comes first, south. Do south first, and then go 70 degrees, almost 90 again, to the east. So it's right there. So let me put that in. So about like right there. Okay, and actually that one's probably, let me make it a little shorter because he's the weaker man, right? It's probably not as long of an arrow, whatever, I'm being a little too picky. Now, it doesn't say how, in fact, that's their question. Notice it says here, what force should the weaker man apply? See, it said the stronger man pulls with a force of 100, so that's 100. But the weaker man, it just tells us the direction. The other pulls at this. What force should the weaker man? So we don't know. So let's call this W. See, this one's 100. This one's W. Now, I forgot to do the direction. It was, what was it? 70 degrees. This angle here is 70 degrees. Just like this angle right there is 78. Okay. So we got the two vectors, right? We have this vector. This guy's pulling, this guy, the big strong guy, is pulling right here in this direction. The weaker person is pulling in this direction. Okay, and together, what do we want? Well, first off, let's just forget about T. Let's just get their vector. So remember, how do you get a vector? How do you get, anytime they give you a vector, like a direction of something, what do you always do? I hope this part is clear for you. For vectors, what we always do is we take the amount times the cosine of theta. So I'm going to take 100 cosine theta. That'll be the x component. I'm going to break it into the x and the y. And this one is 100 sine theta. So this is the x component. This is the y, meaning there's a sideways. So whenever you do anything at an angle, like a vector, when a vector is at an angle, so this man is pulling the rope in that direction at an angle. Well, that means it's going to have a sideways pull and it's going to have a vertical pull, right? Any diagonal action has a sideways and vertical effect, doesn't it? So this diagonal pull is going to have a sideways to the right pull and an up pull, right? Because this is an up to the right kind of pull. So it'll have a right effect and an up effect. Whereas this one's down to the right, so it's going to have a right effect and a down effect, isn't it? How do we know what those are? Well, you just take the total force, 100, times the cosine of the angle, and then 100 times the sine. Now, what angle? Now, that I'll get to in a minute, but let me first do the other one. The other one's going to be the same thing. It's going to be, but it's W cosine of some angle, comma, W sine of some angle. Now, what are these angles we're referring to? That's what you got to be super clear on. Let me say this as clear as I can. It's got to start from 0. Remember, 0 degrees is right here. 0 degrees is right here. It's got to be from 0 up to the vector. That's the angle. That's theta. Over here, it's going to be from this one all the way to the vector. Again, starting from 0 to the vector. Are you seeing that? Seeing how I did the same thing in both places? I started from 0 and I went up till I hit the vector. That's theta. Here again, I started at 0 and I went up, and around until I what? Hit the vector. You think, why didn't you go down? Because you're supposed to go up. Because these are positive. And now you could go down. Technically, you could. But anyway, I'm just going to go up. So let's go back over here. So what is this angle here? Well, if this is 78, then this angle here, this theta right here is going to be 90 minus 78. It's going to be 12 degrees, isn't it? This is a 12-degree angle, right? Because together they got to make 90, right? 12 and 78 makes the whole 90 degrees there. So that means this is 100 cos of 12 degrees, comma, 100 sine of 12 degrees. See that? And then what about the other angle? The other angle from here all the way to there, what's that going to be? Well, all the way to here is 270, right? We know this is 270 down to here. And then this is what? 70 more. So this angle is 270 plus 70, which is 340. So that's what this angle is. So this angle here, I'll put it up here, is going to be W cosine 340 degrees, comma W sine 340 degrees. Okay, let's make sure this is clear. So this is what you have to do whenever you have vectors. This is how vectors always work. Whenever you're pulling at an angle, you have a sideways and a vertical, an X and a Y. How do you find those? Well, you have to take the amount of pull, 100 or whatever, times the cosine of the angle is always X. Remember, X is always cosine, right? All semester long with X has always been cosine. And the Y is 100 sine of theta. That's always the way it is. I could prove it's because this angle's theta here, cosine is adjacent over hypotenuse. See, I'm sorry, that's not adjacent. Cosine is adjacent. This is adjacent. X is adjacent. Whereas sine, if you do sine is opposite, right? Which is Y. That's Y. Anyway, getting back to it. So therefore, then you just got to find out the trick, though, the part that people mess up is they're not 100% clear on what that angle must be. That angle must be starting from 0. That's the mistake people make. People go, oh, it's 78. I'll put in a 78 here. No, that 78 was north 78 east. That's not from 0. You think, well, this one's 70. No, that was south 70. That's not from 0. So that's the part. I hope you're hearing me on that. This angles we do for vectors, they have to be from 0. Let me write that. Angles in vectors must be starting, or must, I should just say must start. Better English there, huh? Must start at 0. You can't start from which, and you know where 0 is, right? 0 is straight to the right. So how much, right? It must start from 0, go to that. So what's that? That's 12 degrees. What's this one? All the way to there. That's 3 right now. You might say, well, Mr. Rain, couldn't you go down? Yeah, you could. And that, but down is negative. It would be the same. You could make that right there. You could make that negative 20 degrees. That's the same. That'll work on your calculator exactly the same. If you put in here negative 20 degrees, that would give you the same answer. Calculator knows that's the same. All right. So now let's finish up this problem. So, okay, so what does all this have to do with anything? Well, let me roll down here and rewrite what we've gotten it. So we've got 100 cosine of 12 degrees, comma, 100 sine of 12 degrees. That's for the stronger man's pull. And then for the weaker man, we've got whatever W. We don't know what his strength is, his weaker. W just means his weaker strength. Cosine, what's his angle? 340, or you could say negative 20. It'll work either way. Comma, W sine. So the Y values are always sine, 340. Okay, now so what? So I got the vector for the stronger man. I got the vector for the weaker man. Now what do they want? What force should the weaker man apply to his rope so that the piece of farm equipment heads where? Due east. Due east. What does that mean? What does due east mean? due east. You want that, they're pulling on ropes, right? Can you picture it? One guy's, you know, the strong guy's here, you know, pulling, here's the farm equipment right here. And the strong guy's pulling this way and the weak guy's pulling that way. It'll be a little smaller, right? And we want this piece of farm equipment to go straight to the right, due east, straight. That means straight east. Well, if you want it to go straight, if you want this piece of farm equipment to go straight to the right, that means you don't want it to go up. You know, as you're sliding it, you know, it's over here. It's this big farm equipment right here. You want that thing to slide straight to the right, not go up, not go down. What does that mean? Not go up, not go down. That means this and this must add up to 0. Are you tracking with me? Right? Because remember, this is the X component, this is the Y, right? This and this are X, this and this are Y. So what? Well, you want this plus this to equal 0. Right? Because that's the result. That's what you want. You want 100 sine of 12 degrees plus W sine 340 degrees to equal 0. You want Y to be 0. You want them to add up to be 0. Here, let me try to put a big line here and a big plus sign. There we go. You want them to add up to be 0. Why? Because you don't want the farm equipment to go up or down. You want it to go straight to the right. No up, no down at all. Due east, straight to the right. You want this and this. You want the amount this guy's pulling up on the farm equipment and the amount this guy's pulling down on the farm equipment to exactly balance so that the farm equipment only goes to the right. Doesn't go up, doesn't go down. You want the Y components to add up to be 0. So you add up the two Y components to be 0. So now you can solve that equation for W. Let's do it. So subtract 100 sine 12 degrees from both sides. We do that. Boom, boom. And we get W sine 340 is negative 100 sine 12 degrees, right? This is just 0 minus that. Last step, got to finish getting W alone, trying to solve for W, right? What the weaker man's pull needs to be. Divide by sine 340. Divide by sine 340. Boom, cancels out. What does W equal? Time to hit the buttons on the calculator. Make sure you're in degree mode. Those are degree angles, right? Check my mode. Yeah, I'm in degree mode. So negative 100 times the sine of 12 equals divided by sine 340. I'm getting 60.789. So I'm always good with 3 decimals. 789, that's pounds. That's how many pounds of force. Remember, the stronger man's pulling at 100 pounds of force. The weaker man needs to pull at 60.789 pounds of force so that together, that thing will go straight to the right. So notice for vectors, we always just break them into their X and Y, X and Y components. And the X is always the force times the cosine of the angle. Y is always force times sine of the angle. But you got to make sure that angle for vectors start at 0. You got to find the angle starting from 0 to that vector. Then just add those up. And you might think, what about those X? We don't care about the X. I don't care at all about that X. They didn't ask me about that X. All they told me is this thing's got to go straight to the right, due east, which means no up, no down, which means the two Y components have to add up to 0. The amount that the stronger guy's pulling upwards, the amount that the weaker guy's pulling downward have to balance out. They have to add up to be 0 so that there's no up or down movement. And so there we go.